Okay, for this experiment, we're calculating density. So the way that you do that is you turn on your scale because we need to find the mass of an object, and then we need to find the volume, and then we'll divide the mass by the volume. So I'm going to put this copper cube up, and I would record 146.6, and then I would measure the cube in centimeters to get the volume, making sure I line that up right. So that is 2.5 centimeters. Now to find volume, we have to have three sides. So on a cube, it's going to be the same every time. So we say 2.5 times 2.5 times 2.5. Oh, it helps to turn it on. 2.5 times 2.5 times 2.5 equals 15.625. Okay, so that is going to be the volume actually on all three of these cubes because they're all the same size. So now we know the volume on all of them. We could weigh the others. Okay, so this is iron. So the grams of the mass of iron is 127.5. And the aluminum is 46.1. Now looking at these different amounts, you can actually tell which one's the most dense right now before you even divide, because when there's less mass packed into the same area, you know that, or the same volume, you know that that is going to be less dense. So aluminum at 46.1 is less dense than iron at 127.5. Now the way that we calculate this to get the exact answer is we say 127.5, just on the iron here. Oops. 127.5. And then we're going to divide it by the 15.625, which gave me 8.16, and that will be grams per cubic centimeter. And so that gives me the density of iron. And so I would do this on each of the objects. And the complete answers for the data will be listed under notes, so you can get that copied. The other thing we were going to look at is measuring density of objects that aren't easily measured by a ruler. So this is a piece of slate, and we can first weigh it. So it's 3.3, but now we have to find the volume, which is trickier. So I'm going to take this graduated cylinder and I fill it with some water, and I'm just going to pick 60 milliliters. And I have to make sure that it's exactly at 60. Which isn't always easy. And what I'm going to do is watch to see how much the water level rises when I add the piece of slate in there. Okay, just a little bit more. Okay, I think that's exactly at 60. Okay, and so just like when you get in the bathtub and the level goes up, that's what happens here. It's called water displacement. So we're going to see how much it displaces the water. I'm going to turn this so it doesn't get stuck. Okay, now the water level rose about 1 milliliter, if you look on here, and so, which is the same as a cubic centimeter. So we would write 1 milliliter there, and then to find its density, we would go back to the 3.3 that it weighed, that the grams were, and we'd say 3.3 divided by 1 And then that would give us the density of slate.